So for today's story, we need a horse, we need a mouse, we need a key and a lock, and a magic bullet. Well, talking about a magic bullet, let's make one. Here we go. A magic bullet, and a key, and a lock, and a story. Story starts 100 years ago when Paul Ehrlich, physician and a chemist, had a problem with a disease. The disease was diphtheria. This is a bacterial disease that was killing children. It was called the strangling angel because their throat would swell up. They couldn't breathe. Well, together with a colleague, Emil von Behring, they had an idea. The idea was to somehow counter this disease. So they took the bacteria that they knew secreted a toxin. They took that toxin, injected it into a horse, and then they extracted the horse's blood. They separated out the red blood cells, were left with the serum. They then injected that serum into a patient suffering from diphtheria, and miraculously, the patient was cured. Ehrlich said, look, we may have here a magic bullet because something targeted the organism that was causing diphtheria. He called this magic bullet an antibody. Well, today we have learned a lot more about antibodies, and the whole world has opened up. So let me tell you what's happening these days with antibodies. Researchers have discovered that they can take a protein that comes from a cancer cell or from a virus or from a bacterium and inject it into a mouse. The mouse then produces B cells, a type of white blood cell, that crank out antibodies which can target the specific protein that was injected into the mouse. These blood cells can be isolated, and the antibodies also isolated. They're called monoclonal antibodies because they all come from the same type of B cell. And then these antibodies are injected into a patient. And if there's also a bacterium or a virus or a cancer cell that has the same protein on its surface, the antibodies act like a key. They will hunt down that specific protein, which acts like a lock, find it, and destroy it. Today, these monoclonal antibodies are having a huge impact. There are journals, there are books that describe all of the research that is going on. So we can look forward to a time when these monoclonal antibodies can effectively hunt down cancer cells. They can treat Crohn's disease by hunting down tumor necrosis factor alpha, which causes Crohn's disease. Or we look forward to them hunting down the viruses that cause things like SARS, that cause things like COVID. So it turns out that about 100 years after Paul Ehrlich suggested the existence of magic bullet, we've come full circle, and we have monoclonal antibodies that actually behave like magic bullets.